Hi, in this video, I'm going to show you how Scale Up works in Cluster Autoscaler by going over the code. I'm not going to go into all the details, but I hope I can give you a good level of understanding of how Scale Up works in the code. Let's get started. This here is our run function. It runs autoscaler.start. This function basically starts a loop in the background, which updates a cache, and this cache is cache for cloud provider nodes. Now, there are three types of nodes that we need to pay attention to in this code. First is a cloud provider node, which is, as the name suggests, a node in the cloud provider. Second is a Kubernetes node, a node which you get when you do a kubectl get node. Third one is a scheduler node, which is a superset of Kubernetes node with extra information. And apart from nodes, you need to know one more thing. Cluster Autoscaler uses a concept called node groups. Now, this node groups basically means a group of nodes. It has no connection with EKS node groups. Node group in context of Autoscaler is a group of nodes which can autoscale. So when we talk about node groups for AWS, they are the node groups in case of AWS would be an autoscaling group. The node groups in the case of GCP would be a managed instance group. So when we say node groups in Cluster Autoscaler's case, and if you're talking about if you're deploying this Cluster Autoscaler on AWS, the node group here would be equivalent to a cluster autoscaling group. Sorry, autoscaling group in AWS. So back to the code. This thing runs a loop in the background to update the cache of cloud provider nodes. This here is a function which runs forever, and run once is the function that it runs after a scan interval of 10 seconds. So run once is where scale up and scale down actually happen. This is like the meat of our autoscaler code. If we check run once, if you look at this, it filters out expendable pods. So expendable pods are pods which are below a certain threshold of priority. And that priority can be set with expendable pods priority cutoff. We initialize the cluster snapshot with this information and the information around all nodes. So we retrieve all nodes here. This basically queries the Kubernetes, and all nodes here are Kubernetes nodes. So we give that information to initialize cluster snapshot. This function initializes the cache. This cache is the global cache which Cluster Autoscaler keeps to keep track of the state of the world. We get a struct called, we create a map, which is a map of node group name to scheduler node. And this process function returns that. We further process it and get a new node group. We get a new map. This is a function which is run at the very end, so I'm going to ignore it. A few corner cases, like if there are unregistered nodes, delete them. If the cluster is not healthy, don't autoscale. If there are nodes created with errors, just delete them. This function here is interesting. It splits the pods which are unschedulable, and it finds unschedulable pods by from this place right here. So the lister gives us unschedulable pods, and I'm not going to go into what listers are, but we get the unschedulable pods and we split them into two categories. One category is unschedulable pods, which are waiting for lower priority pods to get kicked out. And the second category is unschedulable pods, which cannot be scheduled by kicking out lower priority pods. These pods are what we are going to, these pods are of concern for us because we are going to scale our cluster to fit these unschedulable pods. So we get upcoming nodes. We filter out the young pods from unschedulable pods because we want to give them more time before auto scaling for pods which just came up. So we check if the unschedulable pods to help, that is pods which need auto scaling are 0, don't do anything. If the number of nodes is more than the max nodes, the cluster cannot scale up more than this, do nothing after this. If the pods are very new, wait for next iteration so that the scheduler can pick them up. There might be space in the cluster, but the scheduler, but the pods are so new that the scheduler hasn't scheduled them on any node, for example. And the scaler function is where the scale up actually happens. So we first built what is called pod equivalence groups. So this basically groups unschedulable pods based on their scheduling properties. Check the upcoming nodes. We get the node groups from the cloud provider. We get the resources left in the cluster. And then we loop on the node groups. Now this node group, bear in mind, is a cloud provider, is a list of cloud provider node groups, which would be AHGs. So we check for a bunch of conditions to see if the node group can be used for scaling up. And if we see that it can be used for scaling up, then we do something called compute expansion option. So what this does is it runs a simulation. And in this simulation, it creates a new snapshot of the cluster, and it runs a bunch of checks on the pods which cannot be scheduled. Remember, pod equivalence groups is unschedulable pods bunched together based on scheduling properties. So we run tests on them. So this, when I say test, what I mean is check predicates. So we run check predicates on them. Check predicates is this predicate checker is something that we use from a scheduling framework. That is, we use the same predicate checker as or we do the same kind of predicate checking that scheduler does. What this means is we are simulating if the scheduler can schedule these pods on the nodes that would come up. So the node actually isn't there. We are just creating a simulation to see if the unschedulable pods can fit on the new node. And if it cannot, then it throws an error like this. And we go on to the next pod equivalence group. And we keep on doing that until we find some pods which can actually be scheduled on the new nodes. So when I say predicate, what this means is an example of predicate would be, let's say, for example, the pod doesn't have the right tolerations for the node, in which case, even if the node comes up, the pod cannot be scheduled on it, which means there is no benefit in scaling up our cluster with a new extra node if the pod cannot be scheduled on it. So if all the predicates pass, then we add it to option.pods. And then if we basically build an estimate, and we do this and options. So this option is basically the node count, which would be needed to schedule the option.pods in a particular node group. So we do this for, and sorry, yeah, if we come back and we revert the cluster snapshot, which means we created a new cache, we ran simulation on it, and then we reverted back to our original cache, the original actual state of the cluster. And if we go back, so we compute this option for every single node group. And we have, if you look at this, we have a map of node group to expander option, a map which keeps track of which node, what is the option for each node group. And if the expansion options is 0, there are no expansion options, and it just gives up. But if that is not the case, we come to this piece of code. Now, expander strategy is something that can be set as a flag. So by default, this is random expansion strategy, in which case the best option basically chooses an expander option at random. So it basically chooses a node group at random to scale up. So if the best option is not equal to nil, and then do some checking here, if the node count is greater than 0, we get the node count, and we adjust a new node count based on the max size of the node group, max number of nodes that can be or the max limit of the node group, basically. And we set the new nodes to the max limit. To what this means is, if, for example, the node count is 4, but the node group can only scale to 3 node groups, the new node count needs to be set to 3. Then if the node group doesn't exist, then we create a new node group, and we run the compute expansion option again on the new node group which is created. And this option, we add this option to the expansion option map, which is a map of node groups to expansion option again. And then we recalculate the state of the cluster. Now, remember, node info is a map of node groups to scheduler node info. If we found a scheduler node info, it applies the resource limit and checks how many node groups can be, how many nodes can we scale up based on the resource limits for the cluster. So for example, if the max number of nodes for a cluster is 10 and we are at 9, and earlier we said the new nodes is 3, but we can actually scale up only by 1 node, this is the new number of nodes. So this here is if we want to balance similar node groups, we find similar node groups, and we loop over those similar node groups, and we get the scale up info, which is basically saying how much should each node group be scaled up so that we balance the scaling up, and then we execute a scale up. If there's an error, we run an error, and we calculate the state of the cluster again, recalculate the state of the cluster again, and we return with status.scale-up status, and we get the remaining parts. So for example, if the current node group doesn't accommodate all the unscheduled reports, we say there are some unscheduled reports still remaining, and then the cluster autoscaler scale-up cycle starts all over again. And this keeps on happening every 10 seconds. This is basically what Cluster Autoscaler's scale up does in a nutshell, or how it works in a nutshell. I hope that was useful, and that is all. Thank you.